Hello, welcome back. You've been well. This morning what we're going to do is just a little bit of game dev client work, and then we're going to get on to some TOYA stuff. Specifically, future quiz. I need to check in R&D. Extend, I think it might be a risk of a new version before the EP is done and asked to worth fixing to deploy a list of main shop. I see. So we've just got this video from the client that I'll show you guys. I was trying to get TikTok set up before, but it's just proving difficult today, so we'll do that next time. Yeah, I see. Yeah, you can permanently release. Yeah, okay. Cool. That's good to know. So, what I think is probably the issue is that the numbers in the back end are dialed incorrectly. Would be my guess. I reckon that's what it's going to be. Yeah.
Most people nowadays say, I have no time. Of course you don't. Because you are not aware of the present. You know, the present is represented on your watch by a hairline that is as thin as possible as is consistent with visibility. And so everybody thinks the present is instead of
There we go. General. So what I think is the issue is that okay, we're getting
now. The present
errors.
is the only real time. There is no past. And there isn't a future. And there never will be.
Getting a lot of errors. No fun. Yeah. It does seem to be working though. Yeah, and it does charge. Hmm. That's very strange. I might just close and reopen it just so that it has a moment to realize what's going on. That may be all it needs. Maybe not. It's really hard to debug something when I don't know what the problem is. I suppose it could be something in... Yeah. Yeah. Definitely works on my machine. So the question is then, how is this happening? So he's releasing it. The energy's not going down. Maybe it needs to be like if dial input is less than... That shouldn't make a difference. Watch, it's still like, it's only going to refill. Yes, it's refilling there. Slowly but surely. Very, very strange. Okay. I really don't know why that's happening. Everything should be... Yeah, that's... This could be why. Do we do like an everywhere stop coroutine? No. I think that might be why. I swear it hears me. That could be why. Maybe. Yeah, so let's fail. Hell yeah. Let's do that a few times. We'll give it another go now. Oh yeah. Yeah. See if I can do a build. I may not be able to. Oh, I always forget to fix that. Seems to be working. Hmm. Might be a build specific issue, maybe. Oh my god, I forgot about the sound. It's funny. Oh my god, that scared me. So what should be happening is that it should go down. Yeah, it's releasing there. Alright, weird. Basically, I don't know, which is terrible. We may need to head on site. This should like instantly crash because I don't have the dials plugged in. Yeah, good. Okay, well, I'll let them know that, or once this is uploaded. Yeah. Either way, let's get TOYA stuff going. Once that's done. All right. So, what I want to do today is very simple. It's refine the falling and the splatting, essentially. Because if I come over here, you'll see that, whoops, the splatting is the same kind of everywhere, and I don't want it to be like that. Yeah. Okay. Cool. Just need to send a quick email. Cool. So now that client work's all done, actually I just need to do a push. What I think would be a good use of my time is having a look at these splats and falls, because I would love to get it a little bit more refined. Because at the moment, the way it works is we've got our lattice controller, which has animation data in it, and that just always does this. I think I took out the logic related to full speed variance. Let's have a look. Because I didn't like the way it was. Oh no, I'm still using full speed scaler. But I don't really. Let's up here Carry data, handle position, handle offset. Actually, we can make it. I guess we'll put it in here. Yeah, whatever. And then I want to make a new enum called splat type. Soft, medium, and hard. And then in here, I also want to make, because the old the best way to do it would just be to scale between them, actually. Yeah. We define like hard. Yeah, I think that's the way I'm going to do it. So essentially what I'm going to do is define 3 types of splats, and then depending on full speed, we will lerp between them. So to do that, we need our TOYA lattice data scriptable object. We may, in fact, change this significantly. Now, do we? Because it could just all be contained in the one. Yeah, what I think I do actually is I make a new one. Splat data scriptable object. And then in here we have all this stuff. Yeah. And then TOYA lattice data, instead of having all this stuff, we have splat data. We have 3 splat datas. Splat data soft, splat data, and splat data medium. Yeah. Beautiful. And yes, that's going to make a whole bunch of errors, but we can also in movement, layer movement, splat data, default soft splat data. False. I also probably shouldn't have deleted. Yeah, actually. Let's go back. Oops. Yep. Is that rewritten it? No, fantastic. Default medium splat data. Actually no, let's copy paste over these first. 0, 0.3, 0.15. And let's also copy over the curves. Actually no. thing. There we go. And now we can duplicate these guys. Awesome. And then now what we'll do is we'll override it in here. Yep. Bring back what I just did before. And then it's as simple, when we get all these errors, what we need to do is, instead of my animation data, what we will do is at the top of this, pick, make a splat data signal. Splat data, which is equal to animation data soft for now, and then this gets turned into that all in here. Yep. We also don't care about full speed scalar. Don't care about full speed yet. We will. Just not yet. Cool. So that should be identical, basically. We've still got some errors. Right. Yes. Exit scalar increase amount. Yes. Yes, no, that is useful. So where was that? This is in splat animation. Okay, so you just need to happen a bit earlier. That should be everything, I reckon. Yeah, cool. So theoretically, oh no, I need to assign it. I always forget to assign it. Soft, medium, and hard. Whoa. I did also take out some stuff, so that is fair that it is completely busted. Let's also fix up this camera, shall we? Have a look at TOYA scale 1, don't you? Yep, there we go. Yeah, okay, so that's a massive splat. Yeah. So, yeah, it's going way too low. This needs to be like half. Same with this. Yeah, let's try that. There we go, that's better. It's still a bit big on the old this. Let's try 0.5. Ah, I see. Yeah. It's not that, it's this. Let's try dividing this as well. And scoping out this curve a bit better. Let's try that. Yeah, there we go. I feel like that feels good. It might need a little bit more. Cool. I think I like that as let's bring this back to where it was. Whoa. Is that weird for a second or am I crazy? Game. That feels a little odd. I feel like it could be delayed a bit more. Just a little. Yeah. Let me just make sure I'm editing the right curve. You're... Yeah, okay, good. Yeah, that's definitely the right curve. Yeah. Cool. That looks pretty good to me. What I will also do is contour. Yeah, John TOYA. Good morning. I'll also experiment with some constraining of it. Try that. That's pretty good. Yeah, that feels pretty good. Yeah, I like that. Cool. Let's have a look now at the... Actually, let's go into code and change this to looking at the medium splat data. And see how crazy we can get with it, basically. Medium splat data. I think I want to increase it by a little. Basically increase everything by a little. I also want to grab the new curves that I've made, these guys, and update them so we get the new ones. I think basically we want it to be only a little bit deeper. So we got to leave room for the craziness that is like a hard fall. And this needs to go, let's go to like, here. And with a bit of that action. See what that looks like, shall we? Looks pretty good to me. Wow, have I got that in one? I'm pretty happy with that. I think that looks really good. Yeah, I like that a lot. Cool. Let's duplicate this guy and delete him and change this to hard. And then in my default, put the hard one in there. And then the hard one, let's go a little bit crazy with it. Hell yeah. It's probably going to be too much, but there's only one way to find your upper bounds. That is by pushing them. Yes. Oh, wow, that's really good. Oh. Yeah. Yeah. I like that a lot, actually. Yeah, that's like perfect. We could go wider on the sides even. Could go further out. Actually, let's check that it doesn't go more than one unit. Because I don't want it to like accidentally squish stuff on the sides. So we fall, splat. Oh yeah, that's some good splattage. Group. Yeah. And Dan can dial these all in, of course, but I'm just getting him started, really. I think it wants to come up more afterwards as well. Yeah, there we go. Yeah. So that's in, out. It needs to come back in a bit at the end, I think. But no, it's not like that, more like this. Something like that, and then more. Should multi-screen one. Now I can see all the chats. There we go. I'm always wary of putting little bits at the end of the curve because they do like little wobbles that don't quite line up, but yeah. Yeah, that's close. That's close. I think the issue is this. Let's make these guys flat again. Yeah. Yeah, I don't like the little blip at the end. A little harsh for my taste. Yeah, let's try that. Close. I do want to. Okay. Maybe a little. Like this guy's going a little. He needs to go a little over. Just less. And then when is this guy actually doing that? It's around like 0.85 would be the maximum of that. So just like at 0.85. Yeah, a little something like that. Let's try that. Pretty good. Pretty good. I reckon, oops. I reckon Dan will want to do something else with it, but I'm pretty happy with that. Cool, all right. Now let's calculate our thresholds. So, in our splat data, we will need, let's change this to be like this. That's what streaming general should look like. Hey. Back in our scripts, in our splat data, maybe in the splat data itself. No, in the lattice data. We've got our three things, and then we'll also do. Yeah, I guess an array. Why not? Serialized field of a public array of floats called splat thresholds. It listens to me. I am sure of it. It knows what I'm going to do next. I'm also going to do a space here to make things more readable. And then these should also be members, actually. You are a member. You are a member. Cool. Yeah. Hmm.
Hey.
Hmm. Pondering. Pondereth. Hmm. And then what we could also do is just have private. Actually, no, they're not going to need to be private, but they will be hidden. And then just basically all of this data. Again. But this time, it's going to be hidden. Because... actually, no, it's not.
Hey.
But we might need to have some methods in here to help us out. Can we have methods? I forget. I think we can. Yeah, no, we can. What I might do... Yeah. Yeah, that makes sense to me. Okay, so what we're going to do, this is a slightly programmatically tricky thing. We've got our 3 splat datas, and splat data contains quite a few things. Now, if it was just numbers, this would be more straightforward, but because it's not just numbers, we've also got curves. What I'm essentially thinking is that the splat data soft will get a value that will be like our minimum speed, and if we'll like use it sort of like an animation blend tree, in that soft data is what happens when we do a soft splat, hard is obviously when we do a hard splat, and medium's in the middle. We'll lerp between those based on how fast we're falling, essentially. The tricky bit, of course, is that lerping. And so, essentially, what we need to do is that I'm going to bring back these guys again, because I keep forgetting. And just put them down the bottom and comment them out, because I need them to remind me what values we're actually lerping. And then in here, what we're going to put in is this is going to take 2 yeah, let's go like lerp splat duration. And then in here we need a lerp value, and that's it. Yeah. The tricky bit, of course, is if it's... because we're lerping, like, usually you're lerping between 2 things. We're lerping between 3 things, which makes things ever so slightly harder. In that, say our value is 0.25. So if lerp value is less than or equal to 0.5, then we do lerp between soft and medium. Lerp between medium and hard, but this is an else if, because we can also just straight up return medium. Yeah. Yeah. And then the other thing is that if it's less than 0.5, then I think we want to double it. Yeah. Yeah. I think so. Like if it's 0.25, that is actually halfway between soft and medium, so doubling it makes sense. But if it's 7.5, that is, yeah, see, that doesn't work. Yeah, no, okay. The way that I had it in my head makes more sense. Tricky. Yeah, okay. Doubling it for 0.25 makes sense, because then it gets it to 0.5. But what if it's 0.4? Doubling it to 0.8 makes sense. Okay, yeah, doubling it works for this. Yeah. But I think this one doesn't work, because if it's 7.5, I think we need a minus 0.5 and then double it. Yeah. Okay, that's what it already did, actually, and I've been sitting here concocting solutions for no reason, because Copilot already solved it for me. Amazing. Thank you. Good. So we double it and then simply lerp. And you're going to get shitty because we don't have a return value. Return type even. So we want to return a mathf.lerp between soft and medium. Yep. And you know what? Just to make our lives easier, we'll do this. And then we could also do this. No, we can't, because we need to specify here. Yeah, you don't need that. So that's essentially the logic we're going to use for this whole thing. I'm just trying to think if we can like generalize it so that it takes like two datas and a t value and returns a lerp between them for a, like a float within them. I might ask Chatty for that. I have several splat datas that I want to loop between based on a lerp value. I would love to learn how I could write a generalized method that takes two splat datas, the variable of those datas I'm lerping between, and the lerp value, and does the rest for me to avoid repeated code. Yeah. Yeah, exactly. Yeah. And then we can worry about that later. Sweet. That's a great solution. Can you teach me a bit about what the means and the first and the TA, TB arguments in those methods, please? Sweet. High level summary. T is a generic type parameter. It makes the method work with any type while staying type safe. T and B are parameters of that generic type. I see. If T is splat data, then A and B are splat data objects. Yep. Function T float select is a delegate function that extracts the float value from a T's instance. So like it does that. The compiler usually infers T from the arguments you pass. You really need to specify it explicitly. Walk through the function you saw. Signature static float left between 3. So T is declares a generic type parameter. Yep. Okay. Yeah. I knew this was a thing, I just didn't know how to do it. So what I'm going to do is type it out so I get a better understanding of it. So we've got I don't know why they need to, and I wonder if they need to be static. Do these methods need to be static? Use a static method when a method is a pure helper that doesn't need an instant state or polymorphism. Yeah, and then these are, oh, pardon me, aren't. Yeah, okay. Yeah. Yeah, okay, cool. Let's try it. Oops. So love to be able to fucking generic helper functions. Let's just do lerp between 3. So we're gonna get a public static float called lerp between 3, which takes a t type. A, B, and C. And then it takes a float. No, and then we need our selector, which is function of that generic type and a float called selector. Selected variable, and then our lerp value. And then we're going to lerp between A and B. Yep. Double it so it works. Lerp between it. And then this one we're going to lerp between B and C by T. And that's it. Cool. And then we're also going to do another one for animation curves, which is going to be public static. Also going to return a float, but this time it's going to take T of A, T of B, and T of C. And it's going to take a function, which is not going to be a float. It's going to be an animation curve, which is going to be called selected curve. And then we do need a lerp value, but we also need a what's it called? When you do like animation curve dot no evaluate value. There's a bit of a tongue twister. Cool. And then this is going to be very similar, except we are going to get we still need to do this because we need to choose our curves, but instead of doing this, we're gonna do we're gonna evaluate both curves. I swear it listens to me. And then lerp between them. And then we'll do the same thing down here. That's it. Yeah. Cool. I like that a lot. Cool. Thank you, Chatty. Great work as always. Cool. And now we do lerp functions. Um, yeah. Yeah. Amazing. Why? Oh, cool. There's an argument for like creating a new one each time, but I think this will work. I don't really know why that's grayed out. Can I do this as T or does it get shitty? Yeah, it does. Because this is like telling it what this generic is. And then... yeah. Can this be called anything? Yeah. Yeah, cool. Okay, so now, back in here, instead of doing this, we're gonna do, actually what we'll do at the top here for now is put in our full speed factor. No, we'll call it, yeah, we'll call it that for now. But this is gonna actually be 0.25 for now. Actually, no, let's start with 0. And then instead of this, we do splat data. Get. We need to go back to animation data actually. Get XZ scalar increase amount. Full speed factor. Now this is the tricky bit because we're evaluating this times TOYA scale. So TOYA scale can just piece off for a moment. Y value is equal to animation data. Yeah, we do need this because that is our thing, but this needs oh my god, this is so complicated. Let's break this up a bit, shall we? Y the value is equal to this, which is that. Why are you shitty? Get Y splat curation. And then I'm going to do the same thing. Actually, let's just focus on this for now. And then I'm also going to get... Oh my god, shut up. No. Yeah. And then it's... Yep. YT value. And then all of that is times by scale. Yep. And I guess we may as well clamp this while we're here. Because this is the T value. Yeah. And then all of this is times by scale to make it work. Right, let's do X and Y. X and Z again. So we need our T XZ value, XZT value even. Which is going to be clamping the delay, timer minus the delay, divided by the full splat factor, I think is correct. Because we've got delay minus splat factor. Yeah. And then we comment this out and do float xz value is equal to get xz value times xz scalar times TOYA scale. Bellissimo. Oops. And you go. And then this is going to be a new region called calculate y and xz values. And then in here we're going to do calculate offsets. No. Good, and you are shitty because you need to be get xz delay. No? Ah, yes. With full speed factor. Yep. And then splat animation. No. This is good. We got full block constraints, splat animation, calculate offsets, set lattice handle positions. And I've got almost no errors. Yep. Cool. So, theoretically, this should, I liked it like this, look exactly the same as it did before. As it often does with good code. Not good code. That's gross. As it often does with code, full stop. Yeah. Hopefully. Good. Who's shitty? Which line is that? 109, 107. Huh. Ah. Maybe they've been unassigned? What I hope it is. Yes, thank goodness. Excellent. That's what I'm looking for. Bellissimo. And then let's do a test of what happens if we set this to 0.25. Because now this should be alert between soft and medium. Pretty good. Pretty good. Cool. And now let's try 7.5. We could do it by like blocks fallen, of course. Hell yeah. I like that a lot. Hell yeah. I love that a lot. So, now what we need to do is figure out our speed constraints. Yes. Which I guess we can just chuck in here. Yeah, okay. So, in our wonderful mover, I forget if I turn on its debugging, will this spit out its full speed? Or do I need to go in and debug that? Because its full speed should be... No, okay, I do need to turn that on. Move executor. Where's falling again? Full start speed, full speed. Yeah. Yeah. Oh. Full max speed. Let's assume that we like our full speed for now. How fast do we fall on just a 1 block fall? What's our max speed? Yeah, cool. Let's call it... Yeah, let's call it 10.75. Sweet. And then, yeah, we need to make a thing for us to fall on. Actually, do we? No, we can just do this. We can move him over and just bring him up. And then when I input, he should fall. I should get it to do a fall when we get turned on, but cool. That was 18. What's my max fall speed? Fall variable container. 20. Interesting. So if we just fall forever, we should cap out at 20. Yeah. How do we feel about that? Let's... Yeah. Yeah, that feels pretty good. Alrighty, well, for now then, let's just do like 10, 15, and 20. Cool, and then the thing we need to do, of course, now is in our splat, we need another variable in here, which is, of course, full speed factor. And then right. No, this is just full speed. Actually, no. This is one of those rare things where I don't actually want to change all of them. Yeah. 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 Right. Yeah. How do I normalize that value within a range? I don't know when it does internal. Oh no, just public. Normalize full speed. Yeah, but I don't want it. Maybe I. That I want to normalize where 10 is 0 and 20 is 1. Each. Meow, please. That's right. You do this thing. Formula. Normalized value is x minus the min divided by the max minus the min. So it's full speed minus soft minus thresholds zero divided by the max minus the min. Yep. Cool. Cool. And that should be it. Because it was already, I think, feeding it that value. No, it was just setting to 0.5. Right, it's the wrong one. Splat animation complete. You are full start speed, okay. No. That's global, isn't it? Yeah. And then just in case in here, we will do Hell yeah. What we could do is map it to a curve. That might be the way to do it, actually. Let's do it like that. That's a fancy way to do it. I like that. Public. Actually, this is private. Min. Full speed. Max full speed. Full speed map curve. And you are not a float, but an animation curve. Amazing. And then this, instead of normalizing it just like this, we just evaluate it. We still clamp it though. Yeah. Inverse lerp though. Actually, no, we still need to normalize, don't we? Except now what we do is this is full speed normal. Full speed. Max full speed minus min full speed. And we can just clamp this. Yeah, and return it. Cool. And then min is 1075-ish. Actually, that's another thing we should do. We should set full speed equals mathf dot clamp to, yeah. And this, let's go like this, I think. Sure. It shouldn't make much of a difference, but yeah. In fact, let's pick up our little guy. Yeah. That didn't look like one to me.
Did you have fun today? Uh-huh. What did you do? Oh, things. You were alone most of the day. Uh-huh. Why didn't you come home to me?
Oh, and this all needs to be divided by units anyway. Yeah, we haven't done any testing for faster. Yeah. Okay. Good to know.
Did you have fun today?
Yeah, splat.
What did you
Somehow that's getting set to a really low number.
do? Things.
It's not good. It's
You
not
were
good.
alone most of the day. Uh-huh. Why didn't you come home to me?
Yeah, okay. Because this should return 1. It's fallen. It's fallen pretty fast. Whee, bloop. Raw full speed. Normalized full speed is where it's getting cooked. Ah, yes, I see. Obviously, this is unnecessary, but we're just debugging, getting it working. There we go. Oh yeah. I like it. I like it a lot. Yes. Somewhere along here we need to normalize it by TOYA. Oh. Yeah, this is the downfall of doing this all in here. Yeah, okay. Yeah, it needs to happen in the thing. Probably in move executor really. There's a max. I have a max speed, don't I? Or like a full variable container. Max speed, yeah. Normalize full speed. And then we can map it elsewhere. But yes, let's also go to here and put in a min full speed. And then all of this, yes. No return, full speed normalized. This gets scaled by my TOYA's scale. Yep. And then when we start the splat, we can normalize full speed here. In fact, we probably don't even need to feed it a value. We can just normalize full speed. Normalized. Get normalized full speed. Yeah. What do you mean? Oh. You should be... You are not local. Yeah. And then you need to be fed a normalized full speed. Normalized full speed. And then this can remap full speed. Where this guy returns, yeah. No, close. Yeah, it's just evaluate. Cool. And last but not least, in my full speed variable container, you've already been set because I've set the default value correctly. You've got a curve. See if this works. And then I need a snack because there's already been 2 hours work somehow. That's a very good start. I like it. I like it a lot. Yep, sick. And then can clean that up in a bit. Cool. I am gonna go have a snack. I'll be back. I arrive. Hello. Sup? Just gonna check my emails super quick. Who else? Yeah, cool. Let's test our wonderful new falling with bigger block kudu. See if that works. See if our scaling does what it's supposed to. And then we might move on to just generally tweaking the movement so that it's a bit nicer. And bringing back some debug controls. Somewhere over here, I think. Oh. Good. Amazing. Oh. Excellent. Okay, that looked good. I have fallen into the water. Where are these blocks? They're part of a moving landmass. Of course they are. And I've just duplicated this out 3 times because I always do that. No moving landmass. I do not want you. Guten. Oh, guten. I don't quite know why the fall stops there. It's a little worrying, frankly. But whatever. That looks good. It doesn't seem to be doing... Yeah, my normalized full speed's 0. Oh, because it's not debugging. Because it's per thing now. Okay. Normalized full speed is being set to 0. Why? Okay, this is 0. Right. Yeah, the maths on that works out though. I do not understand. Let's get even more specific. To be fair, that should be 0. The tricky bit is, of course, when we get higher up. Like, for example, here, it's yeah, okay. What does the full speed get up to? It gets up to 16. Yeah. It's not getting up past the minimum. Is why. I might need to manually write down full speed, unless it's just not scaling properly elsewhere. Like, is this... Yeah, that's getting scaled by a TOYA scale. I guess... Yeah. And we might need to multiply both of these by scale. And so you do not need to get multiplied again. Yeah. That should make sense. Let's see if this breaks everything. Because it might do. That looks pretty good. Yeah. I like that. I like that. I see, yes, that full speed's still getting clamped. Yes. Mm-hmm. It's pretty good. I get the text something.
Vincent, I haven't seen your face, but I know it's you. I can smell the blood on your hands from here.
Interesting. Probably, it might be the cube within it. No. No. Either way, that's pretty good. It's a little heavy. I imagine, yeah, 5 blocks should get it up to max speed.
What's wrong?
Yeah. How long was it there, though? Not that long.
Go on. Pull the trigger.
Yeah. Yeah, sick. Awesome. I'm glad. Cool. So now we can go back into here. Here. And fix up. Where was that? Here. The next thing is probably continuing on the old... I don't really understand why it's... It's probably because... Yeah. Like if we roll from like... Oh, it's because I'm slightly off, that's why. That's snapping me to the grid. Cool, that solves that mystery, that was easy. The next thing is probably this bug, in that I can roll immediately after. I don't disable the movement while I'm latticing. It is quite funny that I keep track of the TOYA inside. Oh, and there's also crushing. Yeah, we need to do crushing again. Okay, let's finish off. Let's fix that one bug that in lattice in merger. When we merge up, let's turn off input. Player brain input. Am I crazy? This input's not a singleton? You are a singleton. I can reference it directly. No, we care about previous TOYA, not my TOYA. We want to player inputs can input else. This should probably be a static variable. Why is it not? Because then all these would need to be static. Ah, whatever. Make me instance for now. Let's make sure that worked. Awesome. We'll probably do for now, I think. Let's push all that stuff. Good. And then we're going to have a look at speeding up things across the board, won't we? So like, yeah, let's start here. It does still feel a little quick. want it to be about as fast as a tap. It's even a little fast. I think this is where it was before. Yeah, alright. Let's just knock, like, step up roll. Let's go like 3-5. Like that. Step down, we'll do the same. Just a little bit less. What if it was just this? Oh, it's very fast. That's way too fast. I like 0.4. And then just a little less aggressive, maybe. I do like this, I just think it needs to be less aggressive. Try something like that. No, that feels too flat. I think it needs to start faster. And then... He step. Yeah. It feels pretty good. Maybe a little less. Yeah. I think I like that. This is good. It's such a classic curve. Just want to even it a little. Not like that. No, I meant like to make it more extreme. And this is super boring. I think this is. What if we go? Doesn't even end up where it's going. I don't like that one. It's probably going to be this. I'll get down to finesse the curves a bit, I think. That feels right to me. And then it's funny that conversely on the step down the ease in and out doesn't feel right. It feels like, oh, does it? Oh, actually no, that feels pretty good. I also want to, on the TOYA, the light, I want you to not hit play a TOYA, yeah. Yeah. Why you still hit play a TOYA? I no understand. That was weird. There's a little pause there because obviously my speed approaches 0. Which could be a vibe. But yeah, why is this reflecting on the cube? That makes no sense to me. Yeah, why? Why? It most certainly looks like it's reflecting. And I wish I could see this. Maybe it isn't. What if let's change it to where it is and see how that changes things. It doesn't seem to make a difference. Interesting. Yeah. I don't understand. Is it because it's a child, maybe? I don't understand. Like you reflect on the ground, yeah. And you reflect on the TOYAs. I just don't want you to cast light on itself. This does not make sense to me. Interesting. Very interesting. It's very tricky. Maybe I should play some of the original level. Let's do that. Actually, I've got one, don't I? Yeah. I think things will break. Almost definitely. Yeah, like immediately. Might need this guy to be starting. Yes. Nope, still lots of errors. I need to assign it in here as well. I think. Or in here? Yes. Hmm. Hmm. Oh. I broke it. I don't know how I managed to do that. I broke it a lot. Right. Okay. Hmm. Very, very strange. What I think I might do is take it back to how it was, and then we might have a go next time at implementing like speeding up over time. See if that works. Yeah, 3 over time, yeah. And then the steps. Very interesting. Yeah. And then the roll down was this, I think. No, it was this. Which I think makes sense. Oh. That was weird. I don't know what happened there. Anyway, let's call it there for today. Because I need to head into town. Do lots of other work. But this has been very fun. Hope you've enjoyed. I think we got some good stuff done there today. Text green, game over. Oh. I should try and make emojis work. That's a very cute emoji. But yeah, I've also got a new background. That I've made some fresh backgrounds, which I think are very cool. And some like new setups. So yeah, I'll see you guys next time. Bye.